Friends, in this video I am going to talk about instantaneous velocity. But before doing that, let me remind you about a fact that you already know. Let us say this is a straight line. This is a straight line, and we want to find its slope. So if you want to find its slope, what you have to do is, first of all, you have to know what is x-axis. Let us say this is x-axis. Now its slope can be found like you just extend this line until it touches the x-axis. So it touched x-axis here. Let us say this point is R. Okay, and you connect this point. Let us draw QS as the perpendicular line on the x-axis. Now if this angle is theta, then the slope of this PQ line is tan theta. Slope is equal to tan theta. Tan theta and tan theta can be written like QS by RS. No problem. Or you can just draw a parallel line from P. This is parallel to X, and this is also again theta, because this and these are parallel lines and this is common line, so this is theta, then this will also be theta. And in that case, if we say this T, then we can write tan theta is equal to QT by PT, no problem at all. Or if we take any random point here on the extended line of PQ, and if we extend it in this direction also further, and we draw a perpendicular from that, a parallel line from that, we connect these two, and this is again theta. So if we write this point A, B, C, so tan theta will be like equal to BC by AB. So all these ratios are same, and all these ratios are actually slope of this PQ line, isn't it? So this is what you may already know, but I thought that I should remind you once again before going to define what is instantaneous velocity graphically. First we will explain what is instantaneous velocity graphically, then in the next video we'll explain it numerically, and then finally we'll do it by using calculus. Okay, so first we have to understand what is instantaneous velocity graphically. Okay, so let us say this is time axis, this is position axis. Okay, this is time in meter, time in second, not meter, time in second, and this is position axis in meter. Now let us say that this is 2 second, this is 2.5 second, this is 3 second, this is 3.5 second, this is 4 second, this is 4.5, this is 5, this is 5.5, and this is 6, and so on. In this axis, let us say this is 2 meter, this is 4 meter, this is 6, this is 8, this is 10, this is 12, this is 14, and so on. Now the position time graph goes like this, let us say. Okay, it goes like that. Now we want to find what is instantaneous velocity at 4 second. So before doing that we have to find what is average velocity. Let us choose these 2 points, 3 second, let us call this point P1 and this point P2 above 5 second. This point is P2. Now if we want to find average velocity centered at 4 second, we have taken 1 second before 4 second and 1 second after 4 second. Okay, so in this case what we have to do is we have to connect these 2 points directly. We have to connect these 2 points and we have to find average velocity. How do we do that? We just draw a parallel line, a perpendicular line from that. This is parallel to x, this is parallel to this is parallel to this axis and this is parallel to time axis. Okay, so this is delta x, how far it has moved by, this is delta t. So average velocity is nothing but delta x by delta t. I have already discussed this in the previous video, x2 minus x1 by t2 minus t1, and from graph you can find how much x2 is, how much x1 is, how much t1 is, how much t2 is. So you will be able to find average velocity, and I have already told you that this average velocity is nothing but the slope of this line P1 P2. Okay, now if we choose these 2 points closer, that means 3 point the point above the time 3.5 and 4.5. so if we choose these points we can again find average velocity, and that average velocity will be the slope of this pink line, isn't it? In that case we will get this much as delta x, this much as delta t, and if we write again delta x by delta t, that will be slope of this pink line, isn't it? Slope of that pink line. In that case also we will get average velocity between 3.5 second and 4.5 second. Okay, now if we again choose even closer points to 4 second. Okay, now you can see that this line is actually becoming like tangent to the position time graph. If we keep decreasing delta t, that means if we come much closer to 4 second and we choose these 2 points, it just becomes slope, it just becomes tangent to the curve. What do we mean by tangent? If this is a graph and we want to draw tangent of this graph at this point then what we have to do, we just have to draw a line such that this line just touches this axis in this point, okay, above this point, then this is called a tangent. So here if we keep decreasing delta t, that means if we come closer and closer to 4 second from both side, from this side and from that side, then this line just becomes tangent, and the slope of tangent gives delta t, gives, you can think like it is also giving average velocity. But delta t, if delta t is so small, very small, infinitesimally small, smaller than what how much small you can think, so it is very small, then we can say that this line becomes just tangent, and the slope of tangent becomes the velocity, instantaneous velocity at 4 second. This becomes, so slope of tangent slope of tangent is instantaneous velocity. Instantaneous velocity. Here you have to use your imaginative power and intuitive power. Okay, if we keep decreasing delta t, this line becomes tangent, and slope of tangent becomes the instantaneous velocity at this time. Okay, so this is already 10 minutes long video. This is graphical representation of instantaneous velocity. In the next video I will numerically explain what is instantaneous velocity. If you guys like this video, please hit the like button and also subscribe this channel. If you like this video and subscribe this channel, then YouTube algorithm will think that these videos are important videos, so they will show this video to more and more people, and finally these videos will reach to the people who really want to watch this kind of video and who really need this kind of video. Thank you for watching. I'll see you soon in the next video.